first discrete distribution that we're going to look at is called the binomial probability distribution. This distribution is used in a very certain context, and it is used particularly when calculating the probability of a certain number of successes out of a fixed number of trials. Now, what that means is it has, to expand on this, we have 4 conditions that must be met. And these form the acronym FIST. The first one is that the number of trials is fixed. So fixed. I stands for independent. Each trial needs to be independent. S stands for probability of success is always fixed. So for each trial, the probability of success will not change. And T stands for that each trial can only have 2 possible outcomes, either a success or a failure. Now, when we look at the success probability as fixed, this probability is generally given as the population probability. And what that means is, well, say there was a mechanic who looked at their data over the past year and realized that there was a relatively stable probability of someone bringing in their car and it passing its warrant of fitness. Now, that probability for this mechanic might be fixed over a long term, but for individual people, this probability will probably not be the same because it will really be determined on the quality of their car and the state that it is in. But when we look over a long term, this probability is fixed. And as a result, it's not given the letter P in the formula. It's given the letter pi. And so in our formula, we have pi is the probability of success. In probability, if a Greek letter is used, that tends to mean that we're dealing with a population probability. Whereas if just a normal letter is used, like a P, that tends to mean the specific probability of a sample or of an individual. We have N, which is the number of trials. And we have X, which is the total number of successes that we want. The formula for a binomial distribution is the probability that x, which is our random variable, is equal to our particular one, is equal to NCX pi to the power of x times 1 minus pi to the power of n minus x, where x must be between 0 and n, and x is a whole number. Now going into this formula a little bit more, the pi is your probability of success, Your 1 minus pi, well, that's just going to be your probability of failure. So right there we have our two different outcomes. And for their powers, if x is the number of successes that we want, then n minus x will be the number of failures. And then we have this coefficient in front, NCX. Now, that is a combination formula, often read as n choose x. And NCX gives us an actual formula of n factorial all over n minus x factorial times x factorial. It can also be written as just in brackets nx. Now for this formula, you can either use this n choose x or n combination with x formula, or in your Casio graphics calculator there is an option, and to access this you're going to go to the main menu, you're going to hit option, you're going to go across until you find probability, and then there'll be a button that says NCR, which is the one that we want. And to use it, you put whatever n is first, then you click the button and you put whatever r is. Now r in our case is our x. The expected value of a binomial distribution is equal to n, the number of trials, times p, the population probability, and the standard deviation is equal to the square root of n times pi, so that's our expected value, times 1 minus pi, which means the variance will just be that squared, or n pi times 1 minus pi. Now I've also put the binomial distribution table in here. Now you're probably not going to use this much in your exam because you have access to a calculator, but it is possible to very quickly get answers for a binomial distribution from the table, given that the probability of success is actually in it. What we can see is that we have our probabilities along the top row, and so you're going to look for whatever probability is in your question. You can see it's limited to only up to 0.5, so if your probability is above that or not in this table, you can't use the table. You're then going to go down to your total number of trials, so say we had 6 trials, and let's just say we wanted to find the probability that if there are 6 trials, we have 2 successes, given a probability of success of 0.15. We go down the 0.15 until we get into the 6 trials section, and then we look for 2, which is our 2 successes there, and so our probability will be here. It's quite simple to use this table, but again, it's limited to what's in it. So, an example. A duck shooter has a probability of 0.4 of hitting any duck she shoots during a hunt. In a hunt where she fires 10 shots, find the probability that she A. shoots exactly 10 ducks. From the context, we know that n is equal to 10. The probability is 0.4, and we want exactly 10 ducks, so that we x equals 10. So we want to figure out probability that x equals 10. Well, that will be equal to, using the formula, we have 10c10 times 0.4 to the power of 10 times 1 minus 0.4 to the power of n, which is 10, minus x, which is 10. Now 10 choose 10, that gives us 10 factorial over 10 minus 10 factorial times 10 factorial. Well, 10 minus 10 is 0, and 0 factorial is 1. So that will be gone. So we get 10 factorial over 10 factorial, which is just 1. Again, your calculator can give you that using the NCR button. So we have 1 times 0.4 to the power 10 times, and 1 minus 0.4 is 0.6, but that's all to the power of 0, which is just 1. And so our answer, probability that x equals 10, will just be 0.4 to the power 10, which is 0.000124 dp. From the table, we can see n is 10. We want x's to be 10, so we're looking at here. And we have a probability of 0.4. 0.4 is this column here. So we're going to keep going down this column until we get to the n equals 10 and x equals 10. So that will be this button here. That value is the same that we had before. Now you can also use the stats mode on your calculator to get this. You can go into stats, which is your second option. You can go into distributions, and you can go across until you get to binomial. For a probability of x equaling a certain value, you can use the BPD button, and then you can enter your n, your probability, and your x value and get the same answer as well. What's the probability she shoots exactly 6 ducks? Well, n is still 10, pi is still 0.4, x is now 6. So the probability that x equals 6, we can use any of these options. If I just use the table this time, well, we're in the same section, but we're looking at 6 now, so we're going to go up a bit. That gives you this one here, and so that will be our answer, 0.1115. You can also use the formula, and so alternatively you could do 10c6 times 0.4 to the power of 6 times 1 minus 0.4 to the power of 10 minus 6, which is 4. 10c6 is just going to be 10 factorial over n minus x, which would be 4 factorial times 6 factorial. That gives you, well, 10 factorial is just 10 times 9 times 8, etc. That means that we could rewrite this as 10 times 9 times 8 times 7 times 6 factorial. The reason I'm stopping at 6 factorial is that 6 factorial is on the bottom, which means that they will cancel. So we get 10 times 9 times 8 times 7 all over 4 times 3 times 2, which gives us 210. And so you could also enter 210 times 0.4 to the power of 6 times 0.6 to the power of 4, and you'll get the same answer. Alternatively, go to the stats mode in your calculator, BPD, chuck in those 3, and we're good. Okay, C. What is the probability that she shoots more ducks than she misses? Now, since she's shooting at 10 ducks, that means that she has to hit more than 5. 5 is the same, that's not what we want. We want the probability that x is greater than 5. Now there's a lot of different ways that you can do this question. Because we know that there are 10 ducks total, we could work out individually the probability that x equals 6, and then add on the probability that x equals 7, add on the probability that x equals 8, x equals 9, and x equals 10. Now that is quite a lot of work. I'd rather not do that. Alternatively, we can calculate, well, if we want x is greater than 5, that must be the same as 1 minus the probability that x is less than or equal to 5. Because x is less than or equal to 5 would be 0, 1, 2, 3, 4, 5, which is all the ones that I didn't just list before. Now in your calculator, the BCD button works out a probability that x is less than or equal to a value. And so you can enter in your calculator n equals 10, pi equals 0.4, and x equals 5, and that will give you this here. If you do that and you put in your calculator, you're going to get a value of 0.8337. or something close to that, which means our probability will be 1 minus that, which gives us a value of 0.1663. In general, we're going to default to using our stats mode in our calculator a lot because it is the quickest and most accurate method. D, what is the probability that she hits nothing, i.e. n equals 10, pi equals 0.4, x equals 0, or you can use whatever method you want here. The probability that x equals 0 is from a table, same section, but we now have 0, so we're looking here, 0.0060. Last question. In 2 separate hunts, she hits less than 2 ducks in both. Now, when we're going for 2 separate ones, that means that we have to essentially look at this like it's a probability tree, where in the first one, she hits less than 2, and then the next one she hits less than 2. And so we're going to be finding the probability that she hits less than 2, and then timesing it by the probability she hits less than 2, because that's what you do when you go along branches in a probability tree. So we first need to know what is a probability that x is less than 2. Well, that's just a probability that x is less than or equal to 1, which you can do in your calculator, or you can do probability that x equals 0 plus probability that x equals 1. We already know the probability that x equals 0 from above. That's 0.0060 plus the probability that x equals 1, going to our table, that's the one below it, 0.0403. So add on 0.0403. That gives us a total probability of 0.0463. Now that's the probability that she hits less than 2 ducks in the first one. So then to find the probability that it's in both, we're going to do 0.0463 times 0.0463, which gives us 0.00214.